Hello, welcome to another module in this massive open online course. Let us start the discussion with the energy and power of a signal. Alright, so let us start first by considering energy of a signal and consider for this purpose a signal xt. Okay, let us start by considering a signal x t, and naturally this signal we are considering this is a function of time, correct. This is a function of time, that is t denotes time, and the energy Ex of this signal x t can be defined as energy Ex of signal f x t is defined as, we can define this as Ex equals integral minus infinity to infinity magnitude x t square dt, that is integral minus infinity to infinity magnitude x t square dt. Alright. For example, consider x t equals e to the power of minus t for t greater than or equal to 0, for t greater than or equal to 0 and 0 for t less than 0. This is also termed as x t equals e to the power of minus t into u t, where u t is the unit step function, that is u t is 1 if t is greater than or equal to 0 and u t is 0 otherwise. This is known as the unit step function. These you should be familiar from a basic course on signals and systems. This is the unit step function. Since this signal is non-zero only for t greater than or equal to 0, Ex would be simply integral, since this is non-zero only for x greater than or equal to 0. So, this is Ex integral 0, Ex is integral 0 to infinity e to the power of minus t magnitude square dt, that is integral 0 to minus infinity e to the power of minus 2t dt, which is equal to minus half e to the power of minus 2t 0 to infinity, that is equal to half. So, we obtain a total signal energy, that is Ex equal to half for x t equals e to the power of minus t into u t. Okay. So, that is the energy of this signal. All right. Now, if Ex for a signal x t, if Ex is finite, that is Ex is less than infinity, that is strictly less than infinity, then x t is termed as a x t is termed as an energy signal. Then x t is termed as a energy signal. That is, if the energy is finite, for instance, similar to what we have seen above, that is the energy of the signal is half, which is a finite quantity. The energy is a finite quantity, right? The signal xt is termed as an energy signal. Okay. Now, let us define the power of a signal xt. Power the power of a signal xt is p of x equals limit t tilde tends to infinity 1 over t tilde integral minus t tilde divided by 2 to t tilde divided by 2 magnitude xt square dt, which is basically the energy. There is, if you look at this quantity here, this is the energy in a window of size t, this integral minus t by 2, this is energy in window of size t tilde. So, this is basically your energy in a window of size t tilde divided by t tilde as, and the limit taken as t tilde tends to infinity. That is, you take the energy in a window of size t tilde, normalize it, divide it by t tilde, and take the limit of this quantity as t tilde tends to infinity. That is the general, that is the definition of the power of any signal, that is the power of any signal xt. Okay. Now, if px is finite, similar to the energy signal, if px, now we have defined the power, if px is less than infinity, that is power of xt is finite, then xt is termed as a power signal. For instance, all right. So, if this is termed as a power signal. If the power of a signal is finite, then xt, the power of the signal xt is finite, then xt is termed as a power signal. Okay. Now, observe an interesting property. If the energy is finite, if the signal is an energy signal, if xt is an energy signal, then the power px equals limit t tilde tending to infinity 1 over t tilde integral minus t tilde divided by 2 to t tilde divided by 2 magnitude xt square dt. Now, this integral minus t tilde divided by 2 to t tilde divided by 2 magnitude xt square dt is less than or equal to the integral from minus infinity to infinity, because this is simply an energy in a window of size t tilde that is less than, right, that is less than or equal to energy in the window of size, that is the energy in the window from minus infinity to infinity. Therefore, observe that this is less than or equal to limit t tilde tending to infinity 1 over t tilde minus infinity to infinity magnitude xt square dt. Now, observe that this quantity is simply the energy of a signal which is finite, because this is an energy signal. Therefore, this is equal to limit t tilde tending to infinity E x divided by t tilde. So, limit t tilde tending to infinity of E x divided by t tilde, E x is a constant divided by t tilde which is tending to infinity, therefore, E x by t tilde tends to 0. So, this is equal to 0 and therefore, what it means that the power of an energy signal P x, that is P x is less than or equal to 0 from the above argument. This we have obtained from above inequality, and we also know that P x is a positive quantity. So, P x is greater than or equal to 0 since P x is a positive quantity or non-negative quantity rather. P x is a non-negative because it is integral minus t tilde divided by 2 to t tilde divided by 2 magnitude x t square dt divided by t tilde. Everything is positive, so this is everything is non-negative, so this is a non-negative quantity. So, the only possibility is that P x is equal to 0. So, P x is equal to 0 for an energy signal, that is the power of an energy signal is equal to 0. So, this implies that basically this implies that P x equal to 0, which basically implies that for energy signal, that is power of an energy signal. So, we get our first principle, that is the power of the energy signal, that is if a signal x t is an energy signal, that is energy E x is finite, then its power is 0. Now, let us look at the energy of a power signal. If x t is a power signal, on the other hand, if x t is a power signal, if x t is a power signal, okay, all right, then the energy in a window of size t tilde, we know this is approximately equal to the power P x into t tilde, because look at this, we have the power, that is P x equals limit t tilde tends to infinity, energy in window of size t tilde divided by t tilde, which means the energy in a window of size t tilde is approximately t tilde times the power P x equal times the power P x, which implies total energy equals limit t tilde tending to infinity energy in window of size tilde of size t tilde, that is equal to limit t tilde tends to infinity P x times t tilde. P x is a constant, t tilde tends to infinity, which means this is equal to infinity. Therefore, we have how we have proved this is basically we have considered the energy in a window of size t tilde, we have said that is P x times t tilde. Therefore, as the window tends to infinity, t tilde tends to infinity, right, the window tends to infinity, the size of the window tends to infinity, naturally P x into t tilde that tends to infinity, because the power is a constant, correct. Therefore, the power in unit time is constant, as time tends to infinity, the total energy tends to infinity naturally. Therefore, energy of a power signal is infinity. This implies that energy of a power signal the energy of a power signal the energy of a power signal is infinity. So, we have that the energy of a power signal is infinity. Now, what kind of a signal is power signal? We have power signals for a special kind of a power signal is a periodic signals, alright. So, a periodic signal, that is a good example of a power signal is a periodic signal. Let us therefore discuss, and periodic signals are very important in the context of communication, alright, and signal processing and several other applications in electrical engineering. So, let us start this discussion about periodic signals. Okay. So, let us consider a periodic signal. Okay. Periodic signal, we know that xt is a signal with period xt is periodic with period t if xt equals x t plus kt, xt plus kt for all t, that is for all t and for all, this is the symbol for all integers, that is for all that is we call xt to be a periodic signal with period capital T if xt is equal to xt plus some integer k times capital T, where capital T is the period for all times small t and for all integers k, alright. So, basically it means something very simple, that is if you take xt and if you shift it, if you consider xt at any integer, that is any integer multiple of capital T later, that is t plus k times capital T, then the signal xt remains unchanged, that is xt is a periodic signal, alright. For instance, one of the very popular examples of a periodic signal is a sinusoidal signal, that is if you have sine 2 pi f t, that is if you have sine 2 pi f t this is a periodic signal, alright. And what is the period? We know that the period f is the frequency, f is the frequency of the sinusoidal signal, the period t equals 1 over f. So, this is basically your 1 over 2 f, this point is 1 over f, this point is 3 over 2 f, this point is your 2 over f and so on. Okay. So, this is basically the sinusoidal signal, alright. Okay. And this is periodic with capital T, and this is also termed as the fundamental period, capital T equals 1 over f is also termed as the fundamental period of the sinusoidal signal, and you can see that it is periodic with t because sine of 2 pi f t equals sine of, that is if you consider sine of 2 pi f t plus some multiple of the period, some multiple k t, which is equal to sine of 2 pi f t plus 2 pi k f into capital T, but we know t equal to 1 by f, which implies f into capital T equals 1. So, this is basically sine of 2 pi f t plus k times 2 pi sine at any multiple, that is k times 2 pi, that is sine of x, plus k times 2 pi is simply sine of x. So, this is sine of 2 pi f t. So, this is basically periodic. So, we have shown this is periodic with period t which is equal to 1 over f. So, the sinusoidal signal is periodic with p equal to t, capital T equals 1 over f. Similarly, when we say a sinusoidal signal does not necessarily mean only a sine signal, it means it can also be a cosine signal, that is cosine 2 pi f t, also cosine, which is a sinusoidal signal, and in general one can consider any sine 2 pi f t plus phi, that is phi is the phase, a is the amplitude. So, we can have a phase and an amplitude. Okay. So, the sinusoidal signal A sin 2 pi f t plus phi has phase phi and amplitude A. Okay. So, this is a general sinusoidal signal which we have shown, that is sinusoidal signal with frequency f, that is a pure sinusoid with frequency f, has a fundamental period, that is the period of this sinusoidal signal is capital T equals 1 over f, that is this signal is periodic with 1 over f. Okay. Now, what is the power of a periodic signal? How to find the power of a power of a periodic signal. Now, the power of a periodic signal, this can be found as follows. This can be found as follows. Let T be the period of the periodic signal. Then we have, from the definition of the power, we have Px equals limit t tilde tends to infinity, sorry, t tilde tends to infinity 1 over t tilde minus t tilde divided by 2 to t tilde divided by 2 magnitude x t square dt. Now, what we are going to do is choose t tilde equals m times capital T, that is we choose t tilde to be m times capital T. So, naturally as m tends to infinity, t tilde tends to infinity. So, instead of tending t tilde into infinity, we can equivalently tend this integer m. So, what we are doing is we are choosing t tilde to be an integer multiple m times t, where t is the period, right. So, this is, realize, note that t is the period of the signal. Okay. So, if t tilde m tends to infinity, this implies mt tends to infinity, this implies t tilde tends to infinity. So, naturally I can use this. So, instead of limit t tilde tending to infinity, I can here equivalently represent this as limit m tending to infinity 1 over m t minus m t divided by 2 to m t divided by 2 magnitude x t square dt. Okay. Now, look at this, this is integral from minus m t by divided by 2 to m t divided by 2. This contains m periods, right, the total duration is m times capital T. So, it contains m periods of the signal, that is, this is the energy in m periods. Now, this signal is periodic. So, energy in m periods is m times the energy in a single period, because this is a periodic signal. Okay. So, that is the property that we are going to use. So, this is basically energy in m periods equals m into because the signal is periodic, energy in m periods is m times the energy in a single period. So, this is limit m tending to infinity 1 over m t minus t by 2 to t by 2, that is single period, m times the energy in a single period, that is magnitude x t square dt. Now, you can see the m's cancel. So, this is equal to, and therefore, there is no m, therefore, limit m tending to infinity is simply 1 over t integral minus t divided by 2 to t divided by 2 magnitude x t square dt. This is the power p x of the periodic, this is the power of a periodic signal. This is the power of a periodic signal. What is this? This is simply the power of a periodic signal, x t is simply the energy in a single window, that is the energy in a single window of size t, that is energy in a single period capital T divided by the period t, that is size of the window capital T. So, the power of a periodic signal, for the special case of a periodic signal, this is energy in window of size t divided by t. Realize that this t is the period of the signal. So, you simply take the energy of the periodic signal in one period divided by the period, that is capital T, and you get the power of the periodic signal, that is p x. Okay. So, let us take again a simple example. Let us again go back to our standard periodic signal, that is the sinusoid example. Again x t equals a cosine 2 pi f t. Let us consider this periodic. This again we said it is a cosine signal with amplitude a, phase phi equal to 0. We said cosine signal is also a sinusoid. So, this is a sinusoid, and more importantly we know the period t This is the period capital T, which is equal to 1 over f. Therefore, the power of this signal is equal to 1 over T minus T by 2 to T by 2 a square cosine square, that is 1 over T, 1 of the period capital T, where T equal to 1 over f, minus T by 2 to capital T by 2 a square cosine square 2 pi f t, which is equal to, now I can bring the a square outside, a square is a constant, a square divided by capital T integral minus T by 2 to T by 2 cosine square 2 pi f t is 1 over cosine 4 pi f t, that is cos square theta is 1 plus cos 2 theta divided by 2. So, cos square 2 pi f t is 1 plus cosine 4 pi f t divided by 2. So, this is now the integral of half between minus t by 2 to t by 2, that is straightforward, that is basically that is half times t plus half integral of cosine 2 pi f t is basically sine, integral of cosine 4 pi f t is sine 4 pi f t divided by 4 pi f evaluated between minus t by 2 to t by 2, which is a square by t into half t. So, that is a square by 2 plus a square by plus a square by t times 1 by 8 pi f sin 4 pi f t at capital T by 2, f into t is 1. So, this is sin 2 pi minus sin 4 pi f t at t equal to minus capital T divided by 2 equals sin minus 2 pi, and you can see that sin 2 pi equals sin minus 2 pi because there is a difference of integer, but anyway it is integer multiple of 2 pi. So, this is basically, so this quantity here equals 0. So, this is a square divided by 2. So, power of the sinusoidal signal of amplitude A, power of your cosine, power of your A cosine 2 pi f t, that is sinusoidal signal A cosine 2 pi f t is fine. In general, you can show that the power of any sinusoidal signal with amplitude A and phase phi is equal to A square divided by 2. It can be shown that power of A this is equal to A square by 2, where A is the amplitude, that is it does not depend on the phase, the power is simply A square divided by 2, where A is the amplitude of the sinusoidal signal. Alright. So, this is a simple module where we have started with the definition of an energy, defined the energy of a signal, defined what is an energy signal, the power of a signal, what is a power signal, also looked at a periodic signal, defined the power of a periodic signal and illustrated how to compute the power of a simple or a very common and frequently used periodic signal in signal processing and communication, that is the sinusoidal signal, whose power is A square divided by 2, where A is the amplitude of the sinusoid. So, we will stop here and look at other aspects in the subsequent modules.